Hi, I'm Bob Sayer, and I'm the General Manager of the newly launched Azure Communication Services platform here at Microsoft.
Hi, I'm Marianne Niskowski, and I'm a program manager working on Azure Communication Services. At its core, Azure Communication Services is a brand new Azure offering that leverages the same enterprise-grade services behind Microsoft Teams. It enables you to deliver video, voice, and chat experiences anywhere your users are across your apps, websites, and mobile devices.
That's right. It's a powerful new service that uses the core foundational capabilities used to power Microsoft Teams, which is used by millions of users every day for video-based meetings, calling, and chat. But now it's available to you through a developer platform. Imagine taking the same chat, voice, and video capabilities and making these rich communication experiences available in your applications, products, and workflows. You can get started with just a few lines of code, and then you can expand with deep customization. There are four main communication services exposed via a selection of APIs and SDKs that allow you to leverage capabilities such as traditional PSTN calling and SMS for text messaging.
And just to clarify, PSTN is Public Switch Telephone Network. This is regular phone calls you receive on your phone, and SMS are regular text messages you get on your mobile device.
That's right. Thanks for the clarification. So we also offer voice and video over IP, so you can make one-to-one calls, or you can meet with groups of up to 50 people, and you can do things like content sharing. And we offer group meetings and chat. And again, you can have one-to-one conversations, or you can have group conversations. Users can keep their chat history or use informal communications with things like emojis, and they can also share files.
Along with these capabilities, Azure Communication Services is built for the enterprise. Building with Azure ensures you get trusted backend performance for your apps, websites, and IoT solutions with global availability. You can now build secure, connected experiences on your website that incorporate a variety of communication modalities. You can also easily enrich those experiences further with intelligence by tapping into other Azure services, like adding real-time translation, for example. And of course, you can't mention the word enterprise without also talking about security and compliance. We get the same secure, compliant, and enterprise scale foundation of Microsoft Teams and Dynamics 365, which themselves are built on top of Azure Communication Services and have over 75 million daily active users.
So we've been in private preview for a little while now, and we really appreciate all the great customer feedback and the customers that have come along on the journey with us. There's a pretty wide range of customers here that have been in this private preview, and they span across industries like telehealth, financial advisors, contact centers, remote assistance, and education. We're thankful to have passionate and creative customers helping us tune our offerings and provide feedback that help us ship a more useful product.
Our partners are building everything from telehealth applications so you can meet with your doctors, to applications for remote assistance and support, even to augmented reality apps for design. And of course, they're building home security applications for remote monitoring.
That's right. So the sky is the limit for these customers and for you using Azure Communication Services. You can now reach your customers across your applications, websites, and mobile. You can use a reliable global platform trusted by millions of users every day. And along the way, you can trust in uncompromised security since we built Azure Communication Services on the most secure and compliant cloud.
Okay, this all sounds great, Bob. Why don't we show everyone what we're talking about with some code?
Let's do it. So I have here an existing medical application appointment application made by the world famous Contoso Med. It's a pretty simple app written in React and Node.js with Cosmos DB as the backend data store.
This Contoso company seems to be an early adopter of quite a few Microsoft products, huh?
Yep, they are. So I can do a couple things here. I can browse by category. So in this case, I'm going to go into cardiologists. I can take a look at the doctors. I can pick a doctor I want to book with and then do some things like set up timing, and then I can book the appointment if I want to. So It's working pretty well, but I think that we can really supercharge the site with Azure Communication Services. For one, I noticed that patients are often missing their appointments. So I think it'd be a good idea to send them a text message on their phone about an hour before their appointment to remind them of their appointment.
Okay, that's a great idea. And that will be something that's super easy to add using Azure Communication Services. We can create an Azure Communication Service resource in the Azure portal, just like any of the hundreds of types of resources available. So I've gone ahead and provisioned a resource already, and you notice that this looks very similar to other resources. We have things like activity log, metrics, diagnostic settings, but something that is unique to Azure Communication Services is the phone numbers tab. So if I'm on the phone numbers blade, I can actually acquire a phone number that will be used for PSTN calling or to send SMS messages. In our case, we want to send a text message, so I've grabbed a US toll-free number, and that will be the number that the message is coming from when we're sending it to the patient. One other thing we need before we get started is found in the keys blade, and that's the connection string. So once I'm here, I'm just going to copy the connection string to my clipboard, and we're ready to go. All right, where do we want to hook this up?
Okay, so in the code on my web front end, I want to add a new checkbox to my form that says get updates via SMS. So then when the patient clicks on the book appointment button, I can post the patient's phone number, and then it'll go into my Node backend, and then it'll trigger the flow.
Okay, yeah, so one option from your web backend is to use our SDK to create an SMS client. Give it the number we got earlier from the portal and send the message. It would only take 3 or 4 lines of code. But you know what's better than 4 lines of code? No lines of code. We actually have a new Logic App connector that we can use to send the SMS message.
Awesome. So from my web backend, I can then call into the Logic App, which will call into Azure Communication Services, which in turn will send the SMS message.
Right. Okay, so let's go over to Portal again, Azure Portal. And here I've already provisioned a Logic App resource, but I haven't filled in any of the steps. And for this case, I'm going to trigger the SMS being sent from an incoming HTTP request. And you can choose from several, like so many different options. There's when an email has been received or a file has been uploaded, even if a tweet was sent out. But for our purposes, HTTP requests will work just fine. Now I'm going to generate the JSON schema by putting in a sample payload. So once I paste this in here, it will generate the schema for me. And we have a to parameter, and this will be the phone number we're sending to, so the patient's phone number. And we also have the message, which will be the message body, what will actually show up in the text, something like don't be late again or whatever. Now we're going to add the next step, which is going to be talking or actually sending the SMS message. And you can see I've already searched for, or I've already used Azure Communication Services before, so it shows up at the top, but you can search in the search bar at the top to find Azure Communication Services SMS. I'm going to select this option, and at the top dropdown, it will load in the phone numbers that I've acquired from the Azure Communication Services resource already. So I'm going to select the number I want. And again, this is the number that's going to be sending the SMS message. Now I'm going to select the to parameter, and that's the phone number we're sending to, or the customer's phone number, and then the message body, which will be message. Now I need to set up connection. So I'm going to add a new connection, manually enter it. And this is where the connection string comes into play. So I'm going to call this Contoso connection, put in the connection string that I got earlier from the keys blade, and create the connection. Okay, once this is all set up and we're happy with how it looks, I'm going to save this, and it will generate an HTTP endpoint for us to use. I'm going to copy that URL and go over to Postman to actually try it out. So once I'm in Postman, I'm going to create a new post request. I'm going to put in that URL that I just grabbed. Now in the body, I'm going to make sure I'm sending JSON payload, and I'm going to put in the message, which will be, don't be late. And with the 2-parameter. Bob, why don't I use your number and send you a text right now?
That sounds great because I'm typically late for my appointments.
So everything looks good here. I'm going to send this off.
All right, awesome. I just got the message. It says don't be late.
Sweet.
Okay, so next up, sometimes patients want to have virtual visits with their physicians. Normally, that would be a hugely complicated feature. You'd have to do things like figure out how to do video, make it work across networks. That would in many cases require a dedicated team and possibly months worth of work. But with Azure Communication Services, let's see if we can get it done in just a few minutes.
I think we can make that happen.
Okay, so before we get started on that, there are a couple of interesting things about the Contoso Med web app. First, it uses its own identity system. You saw that the users log in with their @contosomed.com email address, and we don't have any integration with Azure Active Directory or any other auth provider like Google or Facebook.
That will work just fine. So with Azure Communication Services, you can bring your own identity system. Of course, you could use Google or Facebook or AAD even, but you can also just use whatever you're currently using.
Awesome. So I'll be able to take, say, Dr. 007 at contosomed.com and use that. Great. Okay, so the other thing is, even though a lot of Contoso Med's clients are on mobile, we haven't yet built our own native mobile apps on either iOS or Android. I mentioned earlier that Azure Communication Services have SDKs for iOS and Android and .NET, but for Contoso Med, the web is the only option.
The native SDKs for iOS and Android give that app-like experience that makes it feel more native and natural for target platforms, but we can also use the Web SDK on any web browser on a mobile device that supports WebRTC.
Okay, and I guess that would have a few advantages. Like, for example, the user won't need to download and install an app. They can just click on a link and start their video chat. Okay, so what do we need to do to get started?
There's 2 things we need to do. First, we need to add an endpoint to your web backend that will generate the access tokens. And then our backend needs to pass those tokens to the web client, which will use them to connect to Azure Communication Service and start the video chat.
Okay, awesome. So I have this auth controller on my backend, and this is what we're currently using to log in our users. So I'll do a couple things. One is I'm going to include the communication administration library, which then I can use in this code here to create a communication identity client. And I'm going to instantiate that client with the connection string that I've returned or that I've retrieved from my admin portal. So once I have that identity client, then I can actually do a couple things. One is I can create new users in the system, or I can issue tokens on an existing user. So I'm going to assume that this user has never been created before, and so the first thing I'm going to do is with my identity client, I'm going to create a new user. This is going to create a lightweight directory entry in the Azure Communication Services that's going to be stored by ID. And so using that user response, then I can then call back on that identity client and issue a token for that user. So I'll pass in the user response that represents that user, which will have the ID, and then I'm going to send in a couple of parameters here. These are scopes or permissions that will be embedded inside of the access token that will govern which capabilities that endpoint can have. And so in this case here, I'm going to give the permission to have VoIP calls as well as chat sessions. These 2 are currently supported. We also will be supporting PSTN in the future when we open up PSTN calling. And so this issue token method is going to respond with an access token, and then I can take this access token and return it on the response into my web front end.
Right. So when the doctor or patient clicks the video call button, they'll use this token to connect. What does the client need to do with the token?
Okay, great. So in my React front end, I have this chat dashboard here, and I'm going to do a couple things to set up my calling clients. This chat dashboard is the website that contains the list of people that I can communicate with, and then it'll also take care of the call control when I want to instantiate that call. So in my setup here, I'm going to start setting up my client communication libraries. I'm currently using JavaScript, and so I'm going to include the communication common library as well as the calling library. And then what I'm going to do here is I'm going to take this access token, which is what I retrieve from my backend, and I'm going to create an Azure Communication user credential, and I'm going to store that in my token credential. And so next, I'm going to create a call client object. The call client object is the entry into being able to have access to all my calling capabilities and my communication capabilities, as well as if I want to have any access to the device manager on the client endpoint itself. And so next thing I'm going to do is I'm going to use that calling client to create a call agent, and I'm going to pass in the token credential. Remember that the token credential was created for the user, which includes the information about the access token. And so this call agent now represents an individual user session that I can use to create basically and set up call and communication sessions. So when I have to be able to also listen for incoming calls, and so on that call agent, I'm going to listen for an event called call updated. This will get fired whenever I have any incoming signal that tells me that I have an incoming call. And when I get that signal, I'm just going to go and take that object and pass it into the view, which is the card that will render the actual call. In addition, I'm going to take this agent that represents the user, pass it into my downstream UI controls, and then I'm also going to get the device manager off of the call client, which can be used by the downstream controls to render media, pick the microphone, etc. Finally, I have to do a couple things here. So I have to handle what happens when I want to place an outbound call. And so when I place an outbound call, I'm going to take the selected user, which is a communication user ID, and I'm going to, on that call agent, I'm going to call the call method. And so one thing to notice here is this is receiving an array of IDs. In this case here, I'm just sending one communication user ID because I'm setting up a one-to-one call. I could pass in multiple communication user IDs, which means I'll be calling multiple VoIP endpoints. And then in the future, I can also pass in PSTN numbers there as well. So you can have blended calls effectively with VoIP endpoints as well as PSTN endpoints. You'll also notice if you looked at the documentation for call agent that I have the ability to join a call. And so I can join a call using a group ID, which would be joining an existing group call session. Another thing I'm going to pass into this outbound call are these call options. And so when I set up my call options, I'm going to do a couple simple things like control whether or not I'm muted. But then more importantly, I'm going to, or actually just as important is, I'm going to set up some device information. So on the device manager, which I retrieve from that call client, I can go and retrieve the cameras on my device. In this case here, I'm going to keep it simple and just pick the very first camera that comes back. And then I'm going to pass this into my downstream React controls to use for rendering. And then I'm also going to set up my local video stream in a very similar manner, and I'm going to set this on my call options, which I then pass into the call. So at this point, I have everything set up in terms of my calling clients.
Okay, so that all makes sense. What happens when I have an incoming call?
Okay, so when I have an incoming call, I'm going to use this call card. This is a component in my React application that I'm going to use to render the call. And so you'll notice a couple things. In the prep for getting ready to render this component, I'm going to receive the inbound call object. And on that inbound call, I'm going to check the list of remote participants. So the inbound call will have a list of participants that are on that call, and then I can use that to iterate each one of the participants. And then for each one of those participants, I'm going to come down to this subscribe to remote participant method, and I'm going to do a couple of things on it. First of all, I'm just going to save a list of remote participants so that I can, again, pass this into the render method. Then I'm also going to take care of setting up which streams I'm going to handle for each of those participants. So in the handle participant stream method, again, I'm going to be iterating through one stream at a time. And so what's interesting to note here is for each participant in the call, they can have multiple streams. And so that could handle situations like if I'm logging in or if I'm connecting into the client with my mobile device and my desktop at the same time. And so all I'm going to do is just take each one of those streams and put it in the list that I then pass into my view for rendering. And then the other thing that I need to do is to take care of, I do a couple of things in here which is somewhat more complicated. So I'm going to do things like filtering out redundant streams. So in here I can say, okay, how many streams do I have for this individual user, and then do I want to filter those out? And then effectively I'm just going to pass those into my my stream viewing card so that I can view those later. And then I'm going to do a couple things, which are registering for video stream updated event and any screen share updating events to see if there's a screen share that's coming. So at this point here, I've basically done everything I need to do to handle the inbound call, and all I have to do now is render the media.
Right. So now we're getting the events for participants and streams. How do we render those?
So I have a stream media card here in my React app. And so when I set the state upstream in my call card and in the chat dashboard, then I'll re-render this component. And so I'm going to do a couple of things. I'm going to have access to my stream object, and I can do a couple of things here. So I'm going to subscribe to an event, which is availability change, which will let me know that either the stream is now available or it's no longer available. So in the signaling session, then when the signaling happens to that new participant, there will be some negotiation that happens, and eventually when the stream is available, I'm going to get an availability change event, and the stream will actually become available. And so when the stream is available, I can go instantiate a render object, and off of that render, I can create a view. And the view is going to be used to actually render the stream. And so all I need to do at this point is to take the target of that view and drop it into my HTML, and then it will take care of rendering the stream. So that's pretty much it. So should we give it a try?
Yeah, let's do it.
Okay, awesome. So here we are actually let me flip over, yep, okay, so to my browser. So I'm logged in as a doctor here, so I've got this call button here. I can hit call, and I'll see my own input stream, which I've connected in. I see the signaling changing from connecting to ringing, and as the call gets set up, then I'll see that it's connected, and oh, there you are. All right, so now doctor and patient are talking, all with an embedded chat control. That's awesome.
Nice.
Okay, so last thing. When patients land on the site, they sometimes don't know which specialist they need. So I was thinking we could use chat and bots. And so a patient could communicate with a bot, but then in some cases I want to escalate to chat with a live person.
Okay, that would be a really good feature to add. And I've actually been playing around with Q&A Maker to build some decision trees that help guide users in the right direction for scenarios just like this.
Okay, cool. So what we could do is use our chat SDK to build a chat interface. And then one of the participants could be in the chat. We could be the patient communicating with the bot. But then if the patient gets to the end of the bot's decision tree, then we could take them to a live agent.
Yeah, and I think we can hook everything up using Event Grid and Q&A Maker.
Okay, awesome. Let's give it a try. Awesome.
So Q&A Maker allows you to build, publish, and train sophisticated bots using FAQ pages, support websites, product manuals, or SharePoint files even. They're an easy-to-use UI. You can also add some personality to your bot using the pre-built chit-chat datasets. So in the Q&A Maker portal, I've already have a knowledge base built out here. And you can see at the bottom, there's some pre-built questions, the pre-built chit-chat datasets. And I've also added some more custom questions and answers that will apply to Contoso. Once we're happy with all of these questions and answers, we can go ahead and publish this to Azure, and it should only take a few seconds. And once we get once it's been published, we'll get a HTTP endpoint that we'll use to call into Q&A Maker, and it comes with a key to authenticate with. And then at the bottom here is the question, and that is the question that the customer is actually putting into the chat. So we're going to send that question to Q&A Maker, and Q&A Maker will respond with an answer to that question. And I mentioned we can hook this all up using Event Grid, so let's see what that part looks like. Now I'm back in our communication service resource, and I've navigated to the events page. I'm going to add a new event subscription. We'll call this one Contoso Chat. This will be an Event Grid schema, and you can see here I have lots of different options for types of events we can get signaled about. There's some for SMS, has the message been received or delivered? A few for chat messages being received or edited or deleted. And then, of course, some with having to do with the user. So have users been added to the thread or been removed from the thread? Lots of options we can choose from. For our purposes, we only need the chat message received. So I'm going to go ahead and select that. And now I'm going to add the endpoint type, and we're going to create an Azure function. Actually, it's already been created, and we'll walk through that in a minute. Since this Azure function has already been created, it will auto-populate here in the Functions tab, and you can choose from multiple if you have different functions that you want to choose from. So this all looks pretty good. I'm going to go ahead and create this subscription. And now let's take a look at what's going on in that function that we're calling. Bob, you want to walk us through it?
Yeah, I'd love to. So this is really cool. So I have a couple things here where I need to basically initialize some of the bot information, and then I need to initiate the chat client, and then I'm going to connect the two. So the code that you have highlighted here, the identity response, the bot identity response, and the bot identity, this is getting the bot information so that I can use it down below. And then the next thing I'm going to do is I'm going to create a chat client, very similar to the calling client that we created before. I'm going to use the Azure Communication user credential, and I'm going to instantiate it with the token, which is the access token. And so from there, I'm going to get a chat client thread, which allows me to connect into an existing thread using that thread ID. And so what I want to do is I want to make sure that once the bot is connected into that thread, or this client endpoint is connected into the thread, I only want to respond to messages that are destined for the bot. And so I'm going to do this check here where I say, is the recipient ID equal to the user ID of the bot? And if so, then I can take that message and I can send it off to my Q&A maker, wait for a response, and then I can just validate the response quickly, and then I can send the message back off to the chat thread. And so then one interesting thing here is we talked about, well, what happens if we want to escalate to a doctor or a agent? And so in the code here on line 41, I can do a check on the Q&A maker to see if I'm unable to respond. And if so, then I can go and check to see if I have an available doctor, and then I can add a member to that chat thread. And so all I have to do is specify the user, which is the Azure Communication user ID and display name. And then what I'll do is I'll basically just take that message and on line 52, take it and send it into the exact same chat thread that I was using before. And then the final thing I'm going to do here is I'm going to actually remove the bot user off the thread, because at this point, the live agent is going to take the thread forward with the patient.
Okay, awesome. So now this is all set up, should we give it a try?
Yeah, let's do it.
So I'm logged in here as a patient, and on the home page, I'm going to start a chat with the bot. Let's just say I'm trying to find a doctor. I'm not really sure. So I'm just going to start this chat. Send this out. And you can see the bot responds. Can you please specify which doctor you're looking for? If I click on cardiologist, for example, here, it will show me a couple options. One, I can see the list of cardiologists, and it will send me a link to where all the cardiologists are listed within the website, or I can hit start consultation right away because I just want to talk to a doctor right now. We can see the bot is saying, okay, let's add the doctor. Wait a minute for them to become available. And the doctor has been added.
That's awesome. Okay, so there you have it. We added SMS reminders, video chat, and an AI-powered chatbot that connects you with a real person. And that only took about 15 minutes.
That's faster than you can get a pizza delivered.
I guess it depends on the kind of pizza you like. So while we were working on this, it reminded me that there's another really cool feature that the team's been working on that could have been really helpful here. Soon, Azure Communication Service will have the ability to communicate with Teams users. That means that in any of the chat, voice, or video scenarios that we just showed, one of the participants could have been using Teams.
So, for example, I, as the patient, would have the experience we just showed using the web browser, maybe on my phone, but you, as a doctor, could be using the Teams app you use every day on your desktop?
That's right. And it will be as seamless whether you're using Teams or whether you're not using Teams. And this is something the team is really excited about, and we can't wait to show in the next couple of months.
Awesome.
So to recap, we talked about how Azure Communication Services is a powerful new service that uses the core foundational capabilities used to power Microsoft Teams. It enables developers to build applications that integrate voice, video, chat, and messaging with the power of Azure. And we showed how in just a few minutes we can add SMS, video, and chat integration into any application. You can imagine after doing this integration that it further opens up all sorts of other integrations that you could do with the power of Azure. Like, for example, you could integrate Azure Cognitive Services for live transcription or add face and object recognition.
Or you could add video recording and processing with Azure Media Services.
That's right. And I'm super excited about the Logic app integration. And it was really cool to see us using Event Grid and Azure Functions when we built the app.
Exactly. I can't wait to see all the innovative solutions our users are going to create using Azure Communication Services. So, Bob, I do have a few questions here that I thought we could answer right now.
Sounds great. Let's do it.
Okay, first one, how do I know if I need to use Azure Communication Services, the Teams App SDK, Microsoft Graph APIs, or something else?
Okay, so Azure Communication Services is a platform offering, and it's meant for customers who want to have full control of their experience and effectively build from the ground up with their own user identities. We have server-side integration and we have client integration for those scenarios. Teams is useful for customers that want the full power of the Teams client, where all of the logic is actually already integrated at the UI level. And then we have the Graph APIs, which are a great complement to Teams for doing things like any type of automation around scheduling meetings or subscribing to presence inside of a Teams environment.
Nice. Okay, and then how many people can be in a video meeting, and how about chat?
So as I mentioned earlier, voice and video calling supports up to 50 participants. The number of active audio and video streams, however, is dependent on the device capabilities and the bandwidth. And then chat can support up to 250 participants.
Is Azure Communication Services available globally? If so, which countries?
During our public preview, all of the capabilities, voice, video, and chat services are available to customers globally, but the customer data will all be stored in the US during the public preview. That means that any end user can try it out.
And how is Azure Communication Services billed? Do you need to buy a monthly license?
No monthly license is required. It's billed similar to other Azure services. So that means you basically just pay for what you use.
And what development platforms does Azure Communication Services support?
Azure Communication Services are public REST APIs with service SDKs for .NET Core, JavaScript, Java, and Python, and they're all serviced through the Azure SDK. We have, in addition to that, client SDKs available for iOS, Android, and the web through JavaScript.
Awesome. And one last question here. How can folks get started?
So there's a couple of links here that are super important. Akka.ms, Azure Communication Services, will get you started, learn about the service. You can check out the documentation at the Communication Services Overview page, and then you can go find the SDKs at the Akka.ms ACS SDKs link. In the Azure Communications page, you'll be able to get started with some of the simple samples, learn the concepts, as well as get started building some of our more complicated hero examples.
Awesome. Thank you, everyone, for joining us today.
Thank you.